Good day all. Today we'll be talking about clustering, and as we know, machine learning is divided into two major parts: the supervised and the unsupervised learning. And the clustering is an example of unsupervised learning. And in clustering, we have hierarchical clustering and k-means clustering. So starting with hierarchical clustering. In hierarchical clustering, we have it is divided into three: single linkage, complete linkage, and hybrid linkage. And what we are talking about here is that in clustering, there are different linkages known as complete linkage, single linkage, and hybrid linkage. Now we'll be going to the mathematical aspect of it. Now, when you talk about complete linkage, in this complete linkage, we compute all pairwise dissimilarities between the observations of two clusters A and B and summarize them by the largest of these similarities or called distances. Then in single linkage is same with complete linkage, but in this case, the smallest distance is used between two clusters. Then hybrid linkage, the same thing, but we average the distance. Okay, now let's take an example, a numerical example of this, and we use we can use Euclidean distance, which can be used to measure the distance between the observation. But there are other approaches, which is a correlation based. And when we are done with this, we create a dendrogram. And just like we are going to display. Now look at this. Let's suppose that we have 5 individuals, each with some features. The correlation between each pair of the individuals computed by their measurements on these features is shown below. Use the correlation-based distance to show the corresponding dendrogram based on the complete linkage. Now, this is a correlation-based metrics table provided. Now, we can see in the beginning, all points are in their own cluster. We can see different clusters. Okay. Now, what we need to do next is we compute 1 minus correlation matrix to obtain the correlation-based dissimilarities. In some cases, you don't need to, if a question is given like this, you may not need to subtract it once you see that it's already appearing in this form. However, the first thing we need to do, since we are dealing with complete linkage, we are looking at the maximum distance between the minimum value in the matrix. Now, the minimum value in the matrix table here is 0.04. So what that means is that when we look at 0.04, it falls, the across is 5, then the down the group is 2. So that's 2, 5. So we group 2 and 5 together. Then we recompute the matrix. Okay, so just like the earlier one. So the new elements are coming from similarities. So we now group them together. We pull 2 and 5 together. So we now have 1. 2 is no longer there as a single value. We now have 1, 2 and 5, 3, 4 across and down the group. Now, we now compute the distance. Distance between 2 and 5, then 1. So what do we do? Now, when we look at the maximum distance between, so we now say 2, 1, then 5 and 1. You can see that just like you want to match them together, So we now have the maximum distance between 2 and 1 and distance between 5 and 1. When we look at the table, the earlier table that we have, 2 and 1, the distance between 2 and 1 is what? It's 0.9. You can see, or 1 and 2, whichever, however you look at it. Then the distance 1 and 5, or 5 and 1, is 0.65, as we can see on the table. 0.65. Now the maximum distance between these two pairs is 0.9, and that is what we have. So the entry for these 2, 5, 1 will be 0.9. Then we go again, we compute. And in the table again, we have 2, 5, and 3. So maximum distance between 2, 3, then distance 5 and 3. Then that will give us, when we go back to this table here, that will be 0.59. Like we can see in the main table, 0.59. Then we have 0.15. That is for 5 and 3. Okay. Now, we go to the next one, 2, 5, and 4 on the second table. So we now have the distance between 2 and 4, then 5 and 4. So the maximum distance between them is what? When we look at this, 2 and 4, let's go back to the table. 2 and 4, we can see it's same thing as 4 and 2, 0.53. Then we can also see 5 and 4 is 0.24. Then that settles it. So we now have a new table. We now go back again and check. Now, we now look again into the table. This is what we have. Now we create a new table, which we have here. 1 and 3, 2 and 5. Then we have 4. What do? After looking at the distances, the smallest of all these new distances that we have obtained is what? 0.36. Okay. 0.36. Now, that means we are going to merge 1 and 3 together. Let's look at the table again. You can see that 0.36 is what? 1 and 3. 0.36 is 1 and 3 after you have created a new table. Now, we now bring 1 and 3 together to form a cluster, then 2 and 5, then 4. We go again. 1 and 3, 1 and 3, obviously 0. That's a diagonal matrix. Now we now have 1 and 3, 2 and 5. Now, distance 1 and 3, 2 and 5, then we'll break it down and open it up. We have 1 and 2, 1 and 5, 3 and 2, 3 and 5. Then we have the maximum distance 0.90. When we go through the same process, we have max 0.90, 0.65, 0.59, 0.16. Then we can now see and that's by the time we look at the maximum of all of them all is 0.90. Then we go again 1 and 3, then 4. Then we do 1 and 3, 1 and 4, 3 and 4. The maximum distance between that will give us 0.45, 0.46, then we have 0.56. Now, the table also, we can see that we have 2, 5, and 4. 2, 5, and 4. So that gives us the maximum distance 2, 4, then 5, 4. Then we look at the matrix table. We have the minimum is 0.53. So we merge 4, 2, and 5 together. So we now have this. Now, from here now, we can see that when we say we already obtained 1 and 3, right? Then 1. Then 2 and 5, you can see that is already, there's no other way to go from here. Then what we now do is we create a dendrogram, which is a correlation base for complete linkage. And this is a dendrogram. 1 and 3, we bring it together, and we can see that we have 1, 3. Let's go back there. We have 2, 4, 5. You can see the way it is linked. 2, 4, 5. Then we create 2 and 5. We create 1 and 3, then we match them together. That gives us our dendrogram. So this completes the complete linkage. So the next video, we'll be looking at the single linkage. Then we also look at average linkage. Thank you for listening.